Hello everyone, Matt Bowling here, and welcome to Chemistry. As you go through this course, you will notice that each topic has been created as a YouTube playlist, with each section broken down into its own separate video. This helps the students to stay focused, and also to be able to navigate back to concepts they need to review. As you go through these notes, be sure to have your student notes out as you watch the videos. That way you can add your own notes, as well as work on example problems with me when they appear on screen. For this reason, you will also want to have your calculator and periodic table handy as we go through the notes. The periodic table can be found in Canvas under Additional Course Materials, located on the home page. To get things started, we're going to go ahead and start with Topic 1, which covers Chemistry Essentials. Let's face it, chemistry can be a tough subject, so it's important that we have a good grasp on the essential chemistry concepts that we will be using throughout this course. So with that being said, let's go ahead and get started. We're starting now with Section 1, which is looking at chemistry as a whole and the scientific method. So what is chemistry? Well, that's kind of a loaded question, but chemistry can be described as the branch of science that deals with the following. Number 1, the identification of substances which matter is composed, the investigation of their properties and the ways in which they interact, combine, and change. And ultimately, we want to look at the use of these processes to form new substances. We're going to take a look at all three of these bullets, not only in this topic, but throughout the duration of this course. So regardless of whether we're talking about chemistry or any other science, scientists use the scientific method, which is an organized process used to do research and to verify the work of others. The scientific method is designed in such a way that it's able to produce a solution that can not only be tested, but also can be supported by experimentation. Now, the scientific method may sound like something super fancy that people in white lab coats do, but to be honest, we all use the scientific method to some degree in our daily lives, and we may not even realize it. The scientific method, in a nutshell, is simply this. You make observations and you make an educated guess, which could be construed as a hypothesis, which will then lead into experimentation and data collection to ultimately arrive at conclusions, theories, or, in a very fancy way, scientific law. For example, we may be on social media or out in public and we see things. We notice things. Maybe we see that someone is starting to post pictures with someone else. You make the observation, and so that leads to a question. Are these two romantically involved? That could lead you to make a hypothesis based on the data that you currently have. But ultimately, you're going to have to do some more experimentation, some more data collection. You may need to do some interviewing. You may need to kind of look around and see if you can figure out if there's other pictures out there. But ultimately, you would go through this organized process to come to a conclusion that could be potentially true based on the support from the data that you've collected. Now, granted, that was a terrible analogy, but you get what I'm saying. We all use the scientific method to some degree. And in chemistry, we're going to talk about more specifically what that looks like. So like I said, the scientific method starts out with an observation. You have to notice something first in order to lead to a problem statement and a hypothesis. So observations can be two types. They can either be qualitative or quantitative. Qualitative observations essentially are observations that do not have numbers. You could notice the color. You can notice the texture or odor. It's things that are descriptive. Whereas quantitative observations are numerical. They always have a number tied to it, such as 3.5 meters or 65.7 milliliters. Nevertheless, once you've made some observations, that will then lead to a question or problem statement, which ultimately needs to have a hypothesis. And a hypothesis is a tentative explanation of the observations you're seeing that act as a guide for gathering and checking the information. So you see something and you create a hypothesis, which is a tentative explanation for what you're seeing. Now, this hypothesis needs to be testable. You have to be able to devise an experiment that will test whether or not the hypothesis is true. And we'll get into that in the next slide. But also notice the hypothesis is tentative, meaning it's plausible that it may change down the line. And that's not always a bad thing. So now we get into the experimentation. So what does an experiment look like? Well, first of all, an experiment is a set of controlled observations in order to test a hypothesis. If the experiment that you've devised does not test the hypothesis, it's not good. Now, what does an experiment need to have? It needs to oftentimes include an independent and a dependent variable. Notice they're both variables, meaning they both change or can change, but you need to know what the difference is between the two. An independent variable is the variable in the experiment that you, as the scientist, can control. You can change it. Whereas the dependent variable is directly coming from that. It's what you're measuring. It's what you're observing. So a way to think about it is the independent variable is what will affect the dependent variable. Maybe. Maybe it won't. Okay? But the independent variable is what you control. So let's think about an example. Let's think about an experiment where I wanted to measure plant growth. Right? I have a garden, okay, in my backyard, and I want to see what are some things that would ultimately affect plant growth of anything that I was growing in my garden. Okay? That's the dependent variable. That's what I'm measuring. That is what I'm observing. So the independent variable, well, you could think there's a lot of things that could affect plant growth, but I need to narrow it down to just one independent variable, because if I have multiple variables, then that will affect my results. So I want to choose one thing to see if it will affect plant growth. So let's say my independent variable is soil type. Right? I want to see if different types of soil will affect plant growth. So the independent variable of soil type is what I can control. I can go to the store and buy different types of soil, and ultimately what I'm measuring is, will those have an effect on plant growth? Now, when I do my experiment, I want to make sure that I have at least 3 trials, because if I only have 1 trial, it could have been a fluke, right? 3 trials at least ensures that I'm getting the most accurate and precise data that I possibly can. So if I did this experiment, I would want to make sure I do it at least 3 times for each soil type, so that way I can see if there's consistency. Now, we're not done yet. We need to make sure our experiment is as airtight as possible. When I do an experiment, I want to make sure I have 2 additional things considered. Number 1, I want to make sure I have a control. And a control is the standard for comparison in an experiment. So, for example, let's say, in addition to going to the store and buying different soils, I would want to just have plants planted directly in the ground. No special soil, just the ground that's naturally there in my backyard. Because maybe the soil types will actually not have any effect at all compared to just the regular dirt that's in my backyard. So the control, or the regular dirt, would be my standard for comparison. I would want to compare plant growths for the soil types to the regular ground. But then there's also constants. If you think about, what would affect plants growing? There's a lot of things that could affect plant growth other than just soil types. How much water the plants are getting, how much sunlight they're getting, things like that. So I want to make sure that when I devise my experiment, none of those other variables are changing. I want to make sure they are constant. In other words, these are factors that must remain unchanging in the experiment to ensure results are meaningful. If I have plants with different soils, but the different plants are getting different water amounts, then how do I know it's not the water amount that's changing the plant growth versus the soil? So I need to make sure that the only 2 things that are changing are the independent and dependent variables. So as a result of your experiment, you would continue to do multiple experiments, revise your hypothesis if necessary, to ultimately lead to conclusions based on data, which at that point then, you can then figure out if there's a theory or a scientific law that could come from your experimentation. And that's what would come at the very end. All right, that wraps up section 1. We'll see you later in section 2.